Okay, Dr. Lane, this problem is actually really interesting. So what we do, we have a roller coaster, includes a vertical circle loop of a radius of 20 meters. What is the minimum speed at which the car must move at the top of the loop so that it does not lose contact with the track? So I made a force body diagram out of this, and uh, it shows that at the top of the loop that the normal force and the mg both point down, and at the bottom of this, when it's right here, it is the normal force um, is pointing up, and that the mass times gravity, the mg, is pointing down when it's at the bottom. And that's the interesting thing about this is when it's at the top, you would think the normal force would push up, but because it has contact at the top right here, it is perpendicular to wherever it is touching, so it actually points down, and your gravity is pointing down. So that's what makes this problem pretty interesting to me, and it's cool because you actually see this happen in real life, but you don't. I mean, you don't see all this happen. But now that I've learned and understanding what's going on in circular motion and forces, I can actually, when I'm at a event where there is a roller coaster and it does this, I can actually see it, and it's pretty cool. So what we use is Newton's second law to do this, to continue to solve this. So that the sum of the forces sub t is equal to n plus mg is equal to ma sub x, which is equal to mv squared top divided by the radius. And I manipulate it to read n is equal to mv squared top divided by the radius minus mg. And this gives us the MV top. V top stands for the feet at the stop, actually, and N stands for the magnitude of the normal force, since N is greater than or equal to 0. So we can apply this formula to M times V squared top divided by the radius minus G, which is going to be greater than or equal to 0. So that simplifies down to V top, which is greater than or equal to the square root of gravity times radius. And then knowing that, we can find the minimum speed at the top using this formula right here, which is V top is equal to the square root of gravity times radius. Then I plugged in my numbers, which is 9.8 meters per second squared times 20 meters, and that gives us 14 meters per second.